Hello. You've just read about ways to inspect the slopes and crest of an embankment dam. Let's review. To inspect these portions of the dam properly, you must walk over the slope or crest as many times as required to see the entire surface area clearly. The sequence you follow to inspect the dam really isn't important. What's important is that you look at every part of the surface area on the entire dam. There are two commonly used ways to cover slope surfaces: a series of parallel passes and using a zigzag pattern. Parallel sweeps are recommended for a large embankment dam or one that has a steep slope. The zigzag path is generally preferable when the embankment slope is small or not too steep. At regular intervals during your inspection of the slope, you should stop and look around in a 360-degree circle to be sure you haven't overlooked some important feature. You should carefully inspect the areas where the abutment contacts the embankment. These areas are called the groins. The groins are susceptible to seepage problems and runoff erosion. You inspect the groins by walking along this contact surface before you leave the slope. As with the slopes, when walking the crest, it's important to look at every bit of the surface area. You can follow a zigzag pattern again, or you can walk the length of the upstream shoulder, then cross over to the downstream shoulder and walk its length. The shoulder is the contact point between the crest and the slope. The idea is to follow a logical pattern that will allow you to examine the whole crest area in detail. A useful sighting technique when checking the crest and slope alignment is to center your eyes along a line of markers and move from side to side to view the line from several angles. These markers can be guardrails, posts, pavement stripes, or parapet walls. As mentioned in the text, what you're trying to do is discover any misalignments and irregularities along the crest and slopes. One technique you might find very helpful is to sight along the line of markers with a pair of binoculars. You can also take a photograph with a telephoto lens. Notice how the foreshortening makes the depression stand out. Another technique for identifying distortions of slope or crest is ground level viewing. Let's see what that might look like. By sighting along the crest and slope surface with your eyes near ground level, misalignments and irregularities will stand out in relief, and you'll have a much better chance of spotting them. What we've tried to do in this first video is to show you how to go about inspecting the dam embankment. Remember, we're suggesting these inspection approaches so that you'll have some plan as you begin. After you gain experience and confidence inspecting embankments, you'll probably develop your own routine and special techniques for inspecting dams. Welcome back. Obviously, when we're inspecting the slopes and crest of the dam, we're looking for deficiencies. One major area of concern, as you've just read, is seepage. Seepage is not always a problem. It becomes a concern when it erodes embankment or foundation materials, or when it creates excessive pressure in the dam or foundation. We're especially concerned with uncontrolled seepage, seepage which appears for the first time, or seepage which increases suddenly. Seepage exiting from the downstream slope should be carefully monitored because it could lead to piping. As mentioned in the text, piping is the most serious seepage condition. Unless it's controlled, it will become progressively worse and could cause failure of the dam. Piping begins when embankment or foundation material is carried away at the seepage exit point, forming a pipe. This pipe enlarges or lengthens at an accelerating rate in the upstream direction. More and more material is washed downstream. Eventually, a continuous open path for reservoir water is created, and the dam is breached. Sometimes the piping process will become evident by the presence of a sand boil. Remember that sand boils are the result of excessive seepage pressure. Sand boils usually occur immediately downstream of the embankment toe. Here are some typical examples of sand boils. When a sand boil is noted, have a qualified engineer assess the situation and recommend what should be done. In addition to the groins, remember that conveyance structures through the embankment are especially prone to seepage. This is what seepage adjacent to a water conveyance structure looks like. If you see seepage at any point such as this, consider it a serious condition. Let's look at another visual cue of seepage. Be on the lookout for vegetation on the downstream slope or below the downstream toe that's more lush or green than the surrounding area. Sometimes vegetation can form a horizontal line on the downstream slope. This probably indicates the intersection of the seepage surface with the downstream slope. This is a sure sign that water is at or near the surface. A dye test for seepage can help you determine the source of seepage. Let's see how to do that. First, place the dye in the reservoir at the location where the seepage is suspected of entering the foundation or abutment. Then, check the downstream seepage points. In this case, we can definitely see the reappearance of the dye, confirming that the reservoir is the source of the seepage. Remember that you should record the location, quantity, and flow rate of all seepage points, as well as the level of the reservoir at the time of observation. Now, let's talk a bit about the correct way of measuring the flow rate. If the flow rate's not too great and the seepage is accessible, such as seepage exiting from a toe drain pipe, use a bucket and stopwatch. You can also install a weir for measuring rate of flow. It's a simple matter to read the weir gauge and convert the reading to a flow rate by means of tables. Don't forget, first clear the weir of any obstructions like sediment or vegetation. Then let the flow stabilize before taking a reading. When you encounter sediment buildup in the weir box, try to determine the cause. Sediment is usually from runoff erosion. It could also be an indication that piping is occurring. This is an example of how you always must carefully consider the reason for everything you see as you carry out your inspection. One last thing you want to pay attention to regarding seepage is its clarity. Most seepage you find will be clear. For example, this controlled seepage is clear. However, you may encounter seepage that is not clear, such as this uncontrolled seepage that appears turbid or cloudy. This cloudy or muddy-looking seepage means that soil particles are suspended in the water. In other words, the water is eroding the soil as it travels through the dam or foundation. Piping is occurring. You've just finished reading about a number of deficiencies which you might encounter when inspecting a dam embankment. Now, let's see examples of some of these deficiencies. We're going to look at inadequate slope protection, inappropriate vegetative growth, cracking, slides, depressions and sinkholes, bulging, debris, animal burrows, and surface runoff erosion. Before we look at the problem of inadequate slope protection, let's look at some examples of slope protection that's doing the job. Riprap, and grass, are two of the most common types of slope protection. Soil cement is less commonly used. Notice the ragged appearance of the slope. This is the normal appearance of soil cement. Now, let's see some samples of sites where slope protection has broken down. On the upstream slope, a common problem is beaching. The term beaching is used to describe the condition that results when part of the upstream slope is removed and deposited farther down the slope. First, the slope protection and eventually the embankment material is removed. A flat area, the beach, remains along with the steep back slope. The steep slope is called a scarp. This eroded area lessens the width and possibly the height of the embankment and could lead to increased seepage or overtopping of the dam. The reason that the riprap failed and that beaching occurred is that the riprap was undersized. You should be continually on the lookout for undersized riprap, since this condition will likely result in beaching in the future. Beaching can also occur on a grass-covered slope. When this happens, it's because grass as slope protection isn't effective at the site given the severity of wave action. Other slope protection should be considered. Finally, we showed you earlier what properly functioning soil cement looks like. Soil cement can also erode due to wave action. Only when a large portion of the soil cement layer has been removed and the dam embankment itself is threatened, should you recommend that soil cement be patched or replaced. Let's move to inappropriate vegetative growth. As valuable as a healthy shallow root system is in preventing erosion, there can be too much of a good thing. There are two categories of inappropriate growth: excessive growth and deep-rooted vegetation. When excessive growth is present, problems threatening the dam can develop and yet remain undetected, a very dangerous situation. Vegetative growth can usually be controlled by periodic mowing and clearing. Try to schedule your inspection shortly after mowing has occurred to ensure the greatest visibility of the slopes and crest. And remember, vegetation can attract burrowing animals. These present another problem which we'll talk about in a moment. Deep-rooted vegetation, such as large trees and shrubs, are particularly undesirable. Large trees could be blown over and uprooted during a storm. If this occurs near the dam crest, the resulting large hole left by the root system could breach the dam. Also, piping could begin when an uprooted tree shortens seepage paths. As this seepage dye test shows, root systems of trees and shrubs penetrate into the dam's cross-section. When the vegetation dies, the decaying root system can provide paths for seepage leading to piping. Remember, trees and shrubs more than 2 feet high are undesirable when they're on or near embankment dams. There is agreement among dam safety engineers that when these trees and shrubs are small, they should be cut down. What it comes down to is that once trees and shrubs have been allowed to get large, the problem is much more difficult to solve. The best course is to get rid of inappropriate growth before it gets too big. The text mentions 3 different types of cracking: desiccation, transverse, and longitudinal. Desiccation cracking often develops in random and honeycomb patterns. These cracks are not harmful unless they become severe. Severe desiccation cracking can lead to the formation of gullies. This happens when surface runoff concentrates in the cracks. Deep desiccation cracks that extend through the core could conceivably cause a breach of the dam if the reservoir rises quickly and the soil doesn't swell rapidly enough to seal the crack. Also, if heavy rains fill deep cracks, portions of the embankment material near the cracks may lose strength and a slide may result. Next, let's look at transverse cracks. Remember, these cracks appear in a direction roughly perpendicular to the length of the dam. For this reason, they're serious, because they can create a path for seepage right through the dam. Breaching of the dam could result. Last, let's take a look at longitudinal cracking. This is cracking roughly parallel to the length of the dam. This type of cracking allows water to enter the embankment and can cause adjacent materials to lose strength. Because of the crack's orientation, a slide may result. For all 3 types of cracking, documentation is a must. Photograph or sketch and record the location, length, depth, and width of these cracks carefully. Consult an engineer as necessary to find out the causes of cracking and what can be done to minimize or repair its impact on the dam. Now, let's discuss the characteristics of slides that might occur on the upstream and downstream slopes of an embankment dam. Slides really fall into 2 categories: shallow and deep-seated. Shallow slides don't usually present a threat to the integrity of the dam, but they can lead to obstruction of water conveyance structures and to larger deep-seated slides. Deep-seated slides are usually a serious threat to the safety of a dam. Look for well-defined scarping produced by the movement of embankment material as seen here. Arc-shaped cracks in the slope show us that a slide is beginning. These cracks may develop into a large scarp in the slope at the top of the slide. Well-defined scarping in either the upstream or downstream slope indicates serious structural problems. When this happens, action has to be taken quickly. Get a qualified engineer to determine the cause of deep-seated slides. Depressions and sinkholes are two closely related features. Depressions are usually the result of localized settlement, but can also be widespread. On the crest, this could mean loss of freeboard with possible overtopping of the dam during flood. One way to detect depressions in the crest and slopes is by sighting along fixed points or along the slope. Most of the time, depressions don't represent an immediate danger to the dam, but their location, size, and depth should be written down. Make it a point to check on these depressions often until you're sure movement has ceased. Also, probe to see if there's a void under the depression. Such a void would suggest that you're dealing with a sinkhole rather than a depression. Another distinction between the two is that a depression has gently sloping, bowl-like sides. Sinkholes are, as a rule, steep-sided. A sinkhole is a very serious type of depression. Remember, it's caused by the removal of subsurface material. Then, the overlying material collapses into the resulting void. The presence of a sinkhole can be alarming. It may indicate piping. Possibly failure of the dam may follow. Probe a sinkhole for the presence of a larger void below the apparent bottom of the sinkhole. Check for running water in the bottom of the hole. Remember to photograph and write down the size and location of the sinkhole. Don't forget, get an engineer to look at the situation as soon as possible. Bulging is associated with lateral spreading of the dam or with slides on the slope. If a toe bulge due to lateral spreading is large enough to be visible, it usually means that there's been some loss of freeboard. Have a survey of the crest performed if you think this has happened. What is very serious are toe bulges resulting from slides on the slope. Inspect the area above the bulge very carefully. Look for signs of instability, like cracks and scarps. If you see these signs, get a qualified engineer to identify the cause of the instability and recommend a corrective course of action as soon as possible. Now, let's talk about problems related to debris. Debris is usually seen as floating trees or limbs. The collection of debris on or around the dam isn't an immediate danger. However, it could lead to serious problems. You see, debris can collect and block outlet works and spillways. It can become waterlogged, sink, and block the intakes of water conveyance structures. And if a flood occurs when debris is blocking water conveyance structures, the dam could be overtopped. Burrowing animals are frequently attracted to water and vegetation around embankment dams. Animal burrows can weaken the embankment and serve as pathways for seepage. This is especially true in small embankments with narrow cross-sections. Piping failures can occur when burrowing animals make passageways that connect the reservoir to the downstream slope. If burrowing animals are evident, take steps to have them removed before serious damage occurs. One final embankment deficiency to look for as you inspect the dam is surface runoff erosion. If it's not corrected, more serious problems can develop, such as deep erosion gullies on the slopes, both at the groins and in the central portion of the dam. In extreme cases, these gullies can breach the crest. Surface runoff erosion, or for that matter any deficiency, may be caused by conditions or problems unique to a particular location. Always be alert for such conditions in your inspection and include them in your report. Well, We've had a chance now to look at the remaining embankment deficiencies of inadequate slope protection, inappropriate vegetative growth, deficiencies of cracking, slides, depressions and sinkholes, bulging, debris, animal burrows, and surface runoff erosion. You may want to review the text sections on these deficiencies and have another look at the information presented there.